Okay, today we're talking about the prime factorization of a number. So we've already identified the definition of prime factorization. And now I'm ready to use a factor tree to find the prime factorization of a number. So we're going to create a factor tree. So I'm going to start by finding the prime factorization of a number like 240. I'm going to put 240 inside a box so I can remember that that's the number I'm starting with. And to start my factor tree, I'm going to caret off of 240 with a factor pair that makes 240. And I can choose any factor pair. It doesn't matter. So I can do 10 times 24, 2 times 120, 80 times 3. I can choose any factor pair that makes 240 to start with. So I'm going to do 10 times 24. And then I have to evaluate, is 10 prime or composite? If it's composite, you're going to caret off of the number. If it's prime, I would circle it and my branches on my factor tree would end right there. So since 10 is composite, I'm going to branch off of it. 24 is also composite, so I'm going to branch off of that. So I'm going to list a factor pair that makes 10. Which would be 2 and 5. I don't want to list 10 and 1. 1 is never going to show up on your factor tree because if you were to list 10 and 1, then you're right back to where you started with 10, right? So it doesn't help you get anywhere. So since 2 is prime, I'm going to circle it. Then you're going to ask yourself, is 5 prime or composite? It's prime, so circle it. Then I need a factor pair to make 24. So I can choose any factor pair that makes 24. 2 times 12, 4 times 6, 3 times 8. Any of those will work. So if I choose 3 times 8, then I'm going to circle 3 because it's prime. And 8 is composite, so it gets a caret. Then I need a factor pair that makes 8. 2 times 4 makes 8. If it's prime, I'm going to circle it. If it's composite, it gets a caret. 2 times 2 make 4. They're both prime, so I'm going to circle both of those. After that, I'm done with my factor tree, but now I have to use my factor tree to write out the prime factorization. So I'm going to start with the original number I started with and say 240 equals, and we're going to list these prime factors in order least to greatest as a multiplication problem. Because watch what happens. And I'm going to do them out of order first just to multiply them. So 2 times 5 is 10. Times 3 is 30. Times 2 is 60. Times 2 is 120. Times 2 is 240. So when I multiply these prime numbers at the bottom of my little tree branches, they should multiply to equal 240. Okay? So then I'm going to do each of these numbers in order least to greatest and write them out as a multiplication problem. I have 1, 2, 3, 4 2's. 2 times 2 times 2 times 2 times 3 times 5. And then there's a more efficient way that I can write 2 times 2 times 2 times 2. I can say 240 equals 2 to the 4th power, good, times 3 times 5. And this is my final answer. That's my prime factorization of 240.
What are you going to play?
Okay, to finish up, we're going to go over a couple of tips to remember when you're finding the prime factorization of a number. The first tip is that 1 is not ever in our prime factor tree. It is not prime, it is not composite, so we don't find that inside our factor tree. Then when we list our factors, the prime factors at the bottom, we make sure to list them in order least to greatest. And in fact, I use the word list, but really it's a multiplication problem. So make sure you have multiplication signs in between those numbers. And next, we're going to use exponents to represent repeated factors. So here, my 2 showed up 2 times 2 times 2 times 2 4 times, which is the same as 2 to the 4th power. Okay, that's it.